So here's a quick description of our robotic gun. We have an airsoft gun, a webcam for visual feedback on the Android application, a laser for targeting. We have a Raspberry Pi that is controlling two servo motors, one mounted here to a gear and another one inside. To control the gun operates at about 8.5 volts. And so to interface that with the Pi, we have it connected to a relay. And simply pushing a trigger button would activate the relay and activate the gun. So now we're going to go ahead and fire. And move. So specifically how we're controlling the robotic gun over the internet and cell phone is mainly by the Raspberry Pi. The Pi is configured as a web server. And you type in the IP address, port, and you'll get a web page. And with this we can move elevation. You can shoot. You could start and stop the camera and disable movement. No longer moves. Hopefully by the end of the quarter we will enable, or we would have finished up the autonomous mode. And maybe for the demo we can have this Nerf gun if it's allowed on school. Here's some testing with a laser. The objective was to track a laser and its position, and we were going to use the laser position as feedback so we can guide the gun and hopefully integrate PID, but it turns out that the laser pointer and tracking doesn't work very well in different lighting conditions, specifically during the day. The color of the laser changes drastically and it's actually difficult to track. So here's Python and OpenCV doing some facial tracking. As you see, it tracks my face, and the objective will eventually to have the gun point at not someone's face but toward their midsection and fire. Currently the application runs slow on the Pi, and we are going to look at code optimizations to make this faster and run better. Here we made attempts to make the algorithm run faster. The video is made smaller, and instead of tracking the face, it just tracks movement in general. So here's a quick description of our robotic gun. We have